Welcome back to Algebra Videos. We have 3x minus 3 plus 4x plus 2 equals 27. So how do we solve a problem like this? It looks long, but we're actually going to make it shorter and shorter and shorter until it's solved. All of a sudden, before we even know it, it's all done. So don't let this worry you. This is going to be easy. And as always, with all algebra problems, first thing we're going to do is ignore these words up here in the top, your chapter titles or section titles. You don't need to know those words. They're absolutely meaningless, worthless, and useless. All you need to know is how to do the problems, and I'm going to show you how to do that. The words don't matter, and you have my permission. I know this sounds wonderful. You have my permission to completely ignore them. Let's just do the problems. It'll be a whole lot easier. So the first thing is just to combine anything that's combinable, anything that looks the same. So we just look in here and we say, hey, look, there's a 3x, and here's a 4x. Those are very similar. We can combine those into just one term. So instead of 3x and 4x, let's just combine those, bring them together, and just call it 7x, right? Because 3x plus 4x is 7x. And then I'll just rewrite the rest of the equation the way it is. We have a minus 3, so minus 3. And we have a plus 2, so I'm going to write plus 2. And that equals, on the right side, 27. So 27. All right, so now we have the exact same equation, but we've combined two of the terms that were very similar into just one term. We combined 3x and 4x to be just 7x. So that makes our problem a little bit easier. And now I want to look through here again at our new equation and see, are there any other opportunities to simplify it or make it easier? Or are there any other terms that we can bring together easily? And I see these two terms right here, minus 3 and plus 2. Minus 3 and plus 2, they could be combined into just negative 1. It would be an easier way of saying the same thing. So I'm just going to rewrite the equation. 7x, that's the same. And instead of minus 3 plus 2, I'm just going to say minus 1. Because negative 3 plus 2 is minus 1, right? And that equals, on the right side, nothing's changed over here. That's still 27. So I'm just going to rewrite that 27. So the next thing I want to do is get rid of that negative 1. So how can I do that? What I want to do, how do you get rid of a negative 1? Make it turn into 0. Well, let's just add 1. So that's what I'm going to do. I'm going to add a 1 to the left side of the equation. Now that's great, but I need to always do the same thing to both sides of the equation, right? Before I forget, I'm going to go over here and put a plus 1 on the other side. And then you might be asking, well, whoa, what are we doing here? Why are we adding 1 to both sides of the equation? Well, the reason is that these two terms here are going to sum to 0. Negative 1 plus 1 is 0. And I knew that, so that's why I put the plus 1 in there. So now when I rewrite the equation, 7x is this part right here. That doesn't change. And then minus 1 plus 1, well, that just turns into minus 0, right? Minus 1 plus 1 is 0. And that equals, on the right side, 27 plus 1 is 28. So our problem is getting easier and easier here before we even do anything. So 7x minus 0 is 28. And we can rewrite this without the 0, right? So let's just do that. 7x equals 28. We're almost there. We just have this 7. So I would like to turn that into a 1 because it's much easier to deal with a 1. So how can I turn 7x into just a 1x? Well, what I'm going to do is I'm going to divide both sides of the equation by 7. Because anything I do to one side, I have to do to both sides. So that's kind of fun. So I get to do that to both sides. And now 7 divided by 7, what's 7 divided by 7? Well, really, what's anything divided by itself? Anything divided by itself, including 7 divided by 7, is just 1, right? So this whole term right here that I'm circling, 7 divided by 7, that is really just 1, okay? And then the x, nothing changes about it. I'm just going to rewrite it down here. So x stays the same. So now we have 1x, or 1 times x, on the left side. And that equals, on the right side, 28 divided by 7 is 4. So 1x equals 4. Well, that can be simply said to be x equals 4. Okay, and I'm going to draw a rectangle around that to show that that is our solution. And so with that, we're done. The only thing is we're not 100% sure, right? We're going to turn it in, and we hope our teacher, gives us, says that that's the right answer, right? It is the right answer, but I want to show you how to verify that that's the right answer. In other words, without even having to wait on your teacher. Of course, in real life, you won't have a teacher, right? You'll have to just do this stuff. So how do we know that x equals 4 is the correct solution? Well, what we do is we plug it back in to the original equation. So I'm going to rewrite the original equation over here on the right. And we're going to take our x equals 4 and we're going to plug it in to each location here where there's an x. And we're going to substitute in a 4 and see if our solution works. So let's rewrite this. 3x, or 3 times x, that becomes 3 times our solution for x is 4. So it becomes 3 times 4. That's this right here. And then I'm just going to rewrite the minus 3. So that's nothing changing there. Same thing, just bringing it down. And then I've got this term, plus 4 times x. So plus 4 times x. And we have solved for x to be 4. So I'm plugging in a 4. And now the next term is plus 2. So I'm going to write a plus 2 right here. And all of that is equal to, on the right side, 27, right? So I'm just going to rewrite the 27. And we'll just keep taking this one baby step at a time. And if these two sides are equal, we know that we got the right solution. So let's do this little piece right here. 3 times 4. That's 12. And then the minus 3, that's this right here. I'm just going to rewrite a minus 3. Okay. And then plus this, 4 times 4. Well, that's 16. So I'm going to say plus 16. And then plus 2. The very end here is a plus 2. So I'll rewrite a plus 2. And that equals, on the right side, 27. Same thing. Still 27 there. So let's combine terms here. Let's just do little baby steps, just a couple pieces at a time. 12 minus 3, that's 9. A little tiny bite there. Plus 16 plus 2. What's that? 18, right? So we're going to write a little 18 there. And that equals, on the right side, 27. No changes here. I'm just bringing this section down right here. Putting it right there. So 9 plus 18 equals 27. Well, what's 9 plus 18? That's 27. Equals, and we'll just bring down our 27 on the right side again. hey, that looks great. Look at this. 27 equals 27. So this equation, which means something that's equal on both sides, worked. When we plugged in x equals 4 up here in the top, we got two numbers that equal each other. We got 27 equals 27. Now, the exact numbers don't matter. As long as you get something that is equal, you want the same thing on both sides of the equation. And if that's true, then you know that your solution was correct. X equals 4. So now we not only solved the problem of x equals 4, we verified that it's correct. And for that, I'm going to give us an A+.
Thumbs up and subscribe. For more videos like this, check out algebravideos.com.